Hello, and welcome to the Web App Security Workshop for the CS166 and full stack of Brown CTF. So in this video, I'll briefly talk about what Web App Security is and what some common vulnerabilities are, and then we'll walk through a try a hack me room to get a feel for how these vulnerabilities might be exploited in practice. So this will be a much shorter version of the Web App Security content covered in CS166 and should give you enough to get started in the CTF. So to start, web apps are applications where a large part of the processing occurs on a web server. So that means that users have to interact with the web server via a client, typically a browser, and that the communication has to occur via requests from the browser to the server and responses from the server back to the browser. So web app security covers attacks involving an attacker that is able to interact with the web app server directly, as well as through the browser. And they're also able to send users to malicious websites or to particular pages on the site. So for this walkthrough, we'll primarily focus on ways to gain access to another user's account, although there are plenty of other attacks you can do, like stealing data directly from the web server. So first, let's talk about how web apps authenticate users if the browser and the server are separated. So although there are variations on this, the most common process is for the user to send a username password pair. Then the server validates this to check that the user exists in their database and that the password is correct. The server then sends back a randomly assigned token for that user. This token is then stored in the browser as a cookie, and the browser automatically includes this cookie in all future requests to the server, which the server can then validate before it performs any actions on behalf of the user. So there are a few places in this process that we might be able to gain access to a user's account. So first, we might be able to guess the username password pair, either by guessing common passwords or brute forcing them. We might be able to bypass the authentication by tricking the server into validating the wrong username password pair. And we might be able to guess the cookie directly, or perhaps we can steal the cookie from the user in some other way. And finally, we might be able to force requests so that the user's browser sends the cookie, even though the real user isn't making the request. So now let's walk through a few common vulnerabilities that might enable us to attack these parts of a web application's authentication and session management processes. So we'll cover three of the most common vulnerabilities that we can use. So there's cross-site scripting, or XSS, Sql Injection, or SQLi, and cross-site request forgery, or CSRF. So the first vulnerability is cross-site scripting. So JavaScript is executed in the browser using script tags. So if we can have our own JavaScript render on the web page, we can launch an attack by stealing the victim's cookie or making requests on their behalf. So there are two primary methods of getting our JavaScript onto the target website. So first, there's stored XSS, which involves getting JavaScript permanently onto the site so that every person who visits a particular page will have that JavaScript execute. So typically, this will be done via some kind of user input, like a comment section. So we can input what looks like a normal looking comment, but include our JavaScript in it. And if the website is vulnerable, then an alert will pop up whenever someone looks at the page with the comment. For this particular example, but of course we can take more malicious actions as well. So the second type is reflected XSS, which is contained within a URL. So sometimes websites will display something that's in the URL, like the name of something you're viewing or a search term. And if the website is vulnerable, then going to this URL will render the JavaScript, but it won't stay on the site permanently. So websites will usually implement some defenses against XSS, like encoding special characters or blocking script tags. If you find that this is the case, however, there are often still ways to get around these defenses. So it's usually worthwhile to be persistent when looking for XSS vulnerabilities. So the next attack is Sql Injection. So websites regularly need to take user input when making database queries, like here, checking the username and password in this example. And if this user input is inputted naively straight into the query, we can potentially craft malicious input to make our own queries rather than being limited by what the server wants us to query. So for example, we first have a query here that checks for the username and password and enters these user inputs directly into the SQL query as strings. So to take advantage of this, we could make our username A, and then use single quotation marks to escape the string, so that SQL stops interpreting our input and starts interpreting it as a query. And then input a SQL command after that drops a user table from the database, deleting all of the users on the website. After that, we can use double hyphens to comment out the rest of the query to avoid syntax errors. So this means that we end up with a query that selects a single user with username A, then drops the entire user table, and then finishes this with the comments instead of the rest of the query. So ideally, we'd bypass the login or steal the cookies, but maybe we can just forge requests instead. So we never know the cookie, but the server thinks that the victim is sending the request anyway. So the thing that will enable us to do this is that cookies are sent with every request to the server that issued them. And for many websites, this will happen even if the requests originate from a different site. So if we can get the user to go onto our site and have our site automatically submit a form on the user's behalf, then potentially the cookie will be included and the server will believe that the real user is making the request. So the code here will request bank.com for a wire transfer to the attacker. And if the user is already logged into bank.com on their browser, their cookie will be sent along with the request to execute the transfer. So in terms of the general approach to take, we first want to learn as much as we can about the target website. So creating an account, if that's possible, trying all of the functionality, and really getting to grips with how the website works. While we do this, we want to be thinking about what parts of the website might be vulnerable to these attacks. So the login system is always a target, but we also want to check for how they're storing session information, as well as things like places where user input is displayed on the website, places where you can upload files you might be able to execute on the server, as well as forms that you might be able to forge. And after that, it's all about crafting interesting payloads to test whether these vulnerabilities exist. So with that, let's go over to the Try Hack Me room and see if we can exploit these vulnerabilities. Okay, so we're now in the Try Hack Me room, which is a website called Wacko Picker. And so it's sort of a file upload site, and you can also buy pictures from other people. So first, we'll have a quick look at some of the developer tools that are available to us, and then we'll look around the site to see if there's anything we can exploit. So the first thing that's going to be useful is the ability to view page source. So if we open this, we'll see sort of the full HTML for that site, as well as places where there's JavaScript that's being used. So this is useful for us in terms of seeing like if there's any forms we might be able to forge, as well as just generally how the site works and what all the options are. However, most of the useful developer tools will be in this inspect option. So we have a few different tabs. One of those is the Elements tab, which shows more or less the same thing as page source, but it also allows us to edit the HTML. So I won't edit it for any other users, but it does mean that we can, for example, disable a particular piece of JavaScript that might be doing some validation and other things like that. There's also the console tab, which might print out logs and error messages, which are useful if we're trying to debug why a particular exploit isn't working. The network tab is quite useful for seeing all of the requests. So this includes the web page itself and also any future requests that might be made. And so we can sort of see what the response is. Something else that's useful in the network tab is that we see the server and the X powered by. So there's really two reasons why this is useful. One is by seeing what the framework is. So here it's PHP. We can sort of prioritize which exploits are more likely to work. So PHP, for example, is more likely to be susceptible to Sql injection, whereas some other frameworks will automatically use prepared statements and sort of protects against that. So in those cases, we might prioritize Sql injection a little bit less. And the final thing, and the other reason why the server and X powered by are useful is that it shows us the version for those frameworks. So sometimes there'll be some publicly known vulnerabilities if they're using an older version of their server or the framework that they're using. Now the final tab to point out is the application tab. So here we can see things like cookies. So this will be really what we're trying to steal in order to log in as a user. And also, sometimes there'll be other things that are being stored, like web SQL and things in session storage, those sorts of things. All right, so let's have a look around the site and see if there's anything that looks like it might be vulnerable. So we won't create an account just yet, but we can check out a sample user. And it just shows a picture that they have. We might notice here that it's sort of querying this by setting user ID equal to 1. And so presumably that's the sample user. But it might be worth seeing what happens if we change this. And there we see Bob and Bob's pictures. So this in itself is really a vulnerability as well. And the key lesson here is that developers often fail to check for things that they don't expect users to do. So there's no button here to go over to other users' pictures, but just by changing the parameter we can. And so we already know one user on the site, and so perhaps we can start by trying to figure out what their password is. But before we do, let's go back. We've also got this what's going on today. So it's got a discount code. We can sort of go through. Doesn't seem to be particularly useful. There's an upload tab, but that's restricted, unfortunately. Sort of recent photos, and that's protected as well. And we've got this guestbook tab. And so there's sort of a comments section here. So potentially there's something we can do with cross-site scripting there. And lastly, we've got a search feature. So if we search here, then we see that that query is in the URL. So maybe there's some reflected cross-site scripting we can do here as well. Okay, so now that we have an idea of sort of how the website works and what some of the areas are where there might be vulnerabilities, let's start by trying to log into Bob's account. So we'll go over to the login tab. And really the simplest attack we can do here is just trying to guess Bob's password. So a lot of the time, websites will allow and users will choose passwords which are quite weak. So things like password, 123456, those sorts of passwords, and often users' own usernames as well. So let's see if we can try a few of those. We can start with password. That didn't work, unfortunately. We can try 123456. Let's try Bob, so its own username. And that was successful. So usually it won't be quite that easy. So a lot of the time, websites will put restrictions on how difficult the password has to be. But we can also try sort of automating this process. So automatically trying lots of passwords to have a slightly higher success rate. All right, so let's say that Pico has put in something like this. So the passwords are strong and brute forcing the password didn't work. Let's see if we can use Sql injection, sort of bypass the authentication process entirely. So in order to test this, one thing we can do is just put in Bob with a single quotation mark. This will hopefully escape the string if it is susceptible to Sql injection. So firstly, we'll know that there's a potential for the vulnerability to exist. And then maybe it'll display some error information that will give us some clues as to how to successfully launch a Sql injection attack. So let's try to log in. And we have a syntax error, which means that firstly, we did escape the string. So that's good. And it also gives us a little bit more information. So we know it's using MySQL. And we can also see roughly sort of the structure of the query. So it looks like it first checks the username, and then afterwards, it checks that the password is correct. So maybe if we can finish the query after it checks the username, then whichever password we enter will never be checked and will just log us in. So let's see if that works. So we'll keep the same Bob and then a single quotation mark to escape it. And then we can use a semicolon to finish the query. And we'll need 2 hyphens to start a comment so that the whole password checking will just be commented out. So let's try this. And that's successful. So Sql injection works here. Sometimes websites will try to have some protections, like preventing you from using a semicolon. in the query. But usually, if they are just passing your query through, passing your input through to the query as a string, then there'll be some ways to escape that. So it's definitely something that's always worth persisting with. All right. So alternatively, it might be the case that there is no Sql injection vulnerability in the login page. Maybe they use like single sign-on from Facebook or Google or something like that, but we don't think we'll be able to find any vulnerabilities. Maybe there are some other ways of getting access to Bob's account, like getting the cookie directly through cross-site scripting. So when we looked at the website earlier, we noticed that in the guestbook tab, there was this comments section. So maybe if we input a script here, we'll be able to steal cookies that way. So let's try this. We can just say we're Bob to sort of cover our tracks a little bit. And then for the comment, we'll get something sort of innocent looking. And then we'll see if we can input a script here. So maybe we can just allot the cookie. And in reality, if we were actually trying to launch this attack, we'd probably send the cookie over to our own endpoint. But for now, allotting should be fine. So let's give this a go. And the cookie appears. So what's happening here is that the website is just directly inputting whatever our comment was onto the web page. And so as soon as it sees the script tag that we have, it starts executing JavaScript. So now if we send this guestbook over to someone, or if someone visits it, the cookie will pop up. Or ideally, it'll be sent to our endpoint. So let's log in as Bob and sort of show how this might work in terms of stealing the cookie. So let's go over to the guestbook. The cookie pops up. So now let's go into an incognito window and show how we can log in with this cookie, even if we never enter the password. Let's go back to the same URL. So we're not logged in as anyone, but let's inspect and go back to the application tab where the cookie was being stored. So here we have some cookie for a non-logged in user that's just been assigned. So let's copy in Bob's cookie and see what happens then. So we've changed the cookie. Now we can refresh. Now it's changed to log out. So let's see, and we're logged in as Bob. So this will be the structure of a lot of cross-site scripting attacks. There are other things you can do other than stealing the cookie. Like, for example, you can make requests directly to the server. But this will be the general structure. So that's cross-site scripting. But maybe there's also a way that we can do some reflective cross-site scripting. So when we search in the search bar, we noticed that the query that we made was showing up in the URL, and then that was being shown here. So maybe if we change the URL to have a script as a query, that script will be shown in the page and executed. So let's give that a go. And we can just change this query to the same thing we had for the stored XSS. Have a script, and then allot the cookie. Put the script again. So the idea would be that we send this URL to like Bob, for example, while he's logged in, and then the cookie is sent. So if we search it, then the cookie shows up. So the script is going from the search into the query, and then is being displayed in the website and executed as JavaScript. All right. So now for a more complicated attack, let's say that we can't figure out a way to sort of bypass the login with Sql injection. There's also no cross-site scripting that's possible, like they're escaping all of the special characters, and that's becoming very difficult. Maybe we can instead forge a request so that we never actually know the password or the cookie, but the server nonetheless thinks that we really are Bob and that Bob's making this request. So to do that, let's log in as Bob again and have a look at how this picture buying process works. Because maybe if we can get Bob to buy one of our pictures, then we can sort of take the money from that, and that'll be a success. So let's have a look at recent. And there's some pictures here. So let's have a look at how this picture buying process works. So there's an add to cart button. we can inspect to have a look at how that works. And so it looks like the add to cart is just a link to a new URL. And so if we click on that, then it's automatically added to the cart. So we know that if Bob goes to this URL, right, with this picture ID, then that item will automatically be added to his cart. So that's useful to know. Now, the next piece of this would be actually checking out Bob's cart. So we can have a look at whether it's continued to confirmation does anything interesting. It looks like it's just a link to the confirm page. So if we go to that, then we have this purchase and a purchase button. So if we inspect the purchase button, we see that it's really an input to a form. And the form's action is to purchase it. So maybe this has some potential for a cross-site request forgery attack here. If we get Bob to visit our HTML page, we can submit this form ourselves. And if something is already in his cart, then Bob might automatically purchase that picture. So there's maybe an attack here. But if we first get Bob to visit that, the sort of add cart URL, so that picture is added to his cart, and then we submit the form on his behalf. So let's have a look at whether this attack might be possible. So the first thing we need to do is to have a HTML page that Bob visits. So GitHub gist, so gist.github.com, is a useful way of hosting files online. So I've got a HTML page here called csurf.html. And let's think about what we need to put here. So the first thing that we want is to open this URL that adds a new item to his cart. Let's add a script. And there's a command called window.open, which will open a new URL. And we'll want this to be open in a new tab so we can still submit the form afterwards. So we'll change the target blank, which will open it in a new tab. And then we just need to find what the URL is that adds an item to Bob's cart. So we save that here. And so that's this cart action. The action is add, and the picture ID is 15. So this is Bryce's picture, but we could make it our own, or maybe we control Bryce's account, something like that. So we'll put that here. But there's another complication here, which is that saying /cart/action or PHP works when we are Wacko Picker. But because we'll be hosting it somewhere else, we'll need to actually put in the domain for Wacko Picker, which in this case is just this IP address here. So we'll have to put this at the start. So when Bob visits this page, he'll open this new tab and hopefully add the item to his cart. But unfortunately, that's not quite enough. It's nice to have an item added to his cart, and maybe he'll buy it himself. But really, we want to force Bob to buy the picture that we want him to buy. So let's have a look at how that confirm page works again. So there was this form with an action to purchase it and an input of submit. And so we imagine that when you click this purchase button, it will automatically buy the picture. So maybe we can view the page source and copy in that form. So here's the purchase form. And let's just copy that into our HTML page. Now it's a little bit messy, but the only thing that we really need here is the form and the input. So let's delete everything else. So that's nice. Now we'll have this form where we can submit to purchase something, but we really want Bob to buy this automatically. So what we can do here is after it's opened, we'll want to wait a little bit. So we can use set timeout to wait. We can take 5 seconds. And after that, we want to click this submit button. So one way to do this is to give the submit button an ID. We can what's called submit. We can identify this input button by its ID. So the command for that is document.getElement by ID. We just specify it as submit. And then we can just do .click to click that button. Now this script will open a new tab with the picture ID to add it to Bob's cart. Then it'll wait 5 seconds or 5,000 milliseconds, and then it'll click this submit button to purchase it. So let's add the URL here as well. And there we go. So this is nice, and we can view sort of the raw HTML page here. But we really want this HTML page to render, so that it really runs for Bob. So to do that, there's a website called Gist Preview. And so there we can just grab the ID of our gist. And then we've got cstuff.html. It's a page we want to access. So let's run that. And we just need to log in again. Let's do that. And let's try running that one more time. Now we've got some items added to the cart. If we go back, there wasn't enough money to purchase it. Unfortunately, there were a few too many pictures added. So let's try one more time, remove these from the cart. Unfortunately, we got too much money out of Bob's account. So let's try that again. Now it's added to its cart, and Bob's purchased a picture. So just by visiting our HTML page, we automatically redirected Bob to the Add to Cart page, and then we submitted that form to buy the picture from Bob, buy the picture for Bob. So now, if we control the account that has this picture, we can presumably sort of transfer the money out. So to summarize, we've covered the process of testing web apps for vulnerabilities, which is really to understand the website and what your capabilities are, and then to test for common vulnerabilities with interesting payloads. We then talked about and exploited some common vulnerabilities. So cross-site scripting, where we get our JavaScript to execute on the website. Sql Injection, where we execute our own Sql commands through user input. And cross-site request forgery, where we create a web page that submits a form or makes a request that automatically includes the cookie. So these attacks should be enough to get you started, but there may be cases where you end up running against attempts by the website to protect against these vulnerabilities. So for example, to protect against cross-site scripting, the website might remove the word script from any comments you enter. Fortunately for you, and unfortunately for the website, there are often ways to get around these offenses. And OWASP is a really great resource for describing defenses and ways of getting around them. So in particular, they have excellent cheat sheets that go into a bit more detail on the attacks we've described here, and also on other vulnerabilities. So I recommend looking at these resources if you want some more information. So that wraps up the Web App Security Workshop. Hopefully this will be useful in coming up with attacks. So good luck and enjoy the CTF.